Let's take a look at the questions on homework number 18. For the first topic, we're going to talk about whether a number is rational or irrational. We've worked on this before, and anything that has a dot, dot, dot at the end is a decimal that does not terminate. That means it keeps on going forever and ever. Sometimes it repeats a pattern and sometimes it does not, like this one here. If you do not repeat the same exact pattern, then you are irrational. And in this case, it's irrational because it is presented to you as a decimal. So we have to choose one of the options that says it's a decimal. It is a decimal, but it doesn't terminate. It goes on forever. So it is a decimal that does not repeat, true, and it does not terminate, true. For this one, it is not given to us in decimal form, and I know that the square root of 36 is 6, so that means it's rational, because it can be written as a fraction. And this is rational because, and if you scroll down here, you can see it is the square root of a perfect square. So read the choices carefully when you're going through the option. If you're not sure if a number is a perfect square or not, you simply type in the square root sign, the radicand, which is the number underneath the square root sign, and if you don't get an integer or a whole number, then it's not a perfect square. So this calculator stops after this character, so you don't actually know if this terminates or if it goes on forever, but it is not an integer, so that means that's not a perfect, square. So this one is irrational, and it was not presented as a decimal, so all of these decimal options are wrong. And so we have to choose one of the square root options because it is given to us in square root form. The square root is not perfect, therefore it is not a rational number. This one on identifying functions we've been doing for a long time, so hopefully you are feeling very confident about your skills in identifying shapes of graphs and naming their styles, right? This one is a square root function because it has an endpoint with only one arrow. Select from an equation from some points. So what I'm going to do is I'm going to work this equation backwards. Instead of trying to figure out whether it's linear, quadratic, or exponential. This one is linear. This one is also linear. This one is quadratic. This one is exponential. I'm going to take a look here. I have a 0, a 1, and a 2 as my inputs or domains. Then I have a 6, a 7, and an 8. I'm noticing that this seems to be continuing with a constant rate of change, right? The pattern of the y's is always plus 1, plus 1, plus 1. Pattern of the x's is always plus 1, plus 1, plus 1. So I'm assuming that this is linear. And the question is, what is the y-intercept? I already know the answer to this, but if you didn't, you could put in your y equals button here. You could clear out everything that is there. And you could simply type in all of these functions. X plus 6, x squared plus 6, even though I've kind of already narrowed it down to just these two options because I noticed that the pattern was linear. But I'm just going to show you what your strategy would be. 6 times the fraction 7/6 raised up to the x power, and then the final choice of x plus 5. So I would go ahead and look at those table of values, and I would look for a 0, 6, which is everything except the fourth one. So I'd cross the fourth one off. And then the second point we had was a 1, 7. So I'm looking for 1, 7, 1, 7. They all have that. So then my third one is 2, 8. So I'm looking for 2, 8, and only this blue function, or the y1 function. And the y1 function was x plus 6. Only that one matches my table of values. So if you're not sure what the pattern is here, or what it's increasing by, or the fact that this one goes by 1 to 2, then it goes from 2 to 4, so it's not linear. And if it doesn't have a constant rate of change, then I know that this one, it can't be right. And I know that this one can't be right, because those are linear. And my pattern here is changing, right? My pattern here was changing. So I might as well just try these two when I'm typing them in to do a guess and check if I wasn't sure what they were. Right? So I can clear these all out. And I'm going to put in just the top two. Parentheses, x plus 1, the whole quantity is being squared, I'm in the y3. It doesn't even really matter. 2 raised up to the x value. Now when I look at my table of values, I'm looking for 0, 1, 1, 2, and 2, 4. So 0, 1 they both have. 1, 2 only the y4 equation has. So y4, which is 2 to the power of x, which is exponential, is the right answer. So that's how you're going to check for this one. Interpreting a box plot, we've done this before. You got to practice your vocabulary. What percentage of the data values are less than 75%? Remember, these are quartiles, 25, 50, 75. So everything from here down is less than 75. What percentage? So 25, 50, 75% are less than this number 75 right here. What percentage of the data values are greater than 45? Well, this is 45 right here, and that's only one quartile, so that's only 25% are going to be greater than that value. Last question, what is the value of the third quartile? This is Q1 right here. The first or lower quartile, the median is Q2, so the third quartile is 78 and 80, so this one must be 79. All right, interpret a line of best fit. So you're going to be looking at these yellow dots and these blue dots. So these dots that are actually on the line of best fit, those are actual and predicted data value points. These yellow ones are the actual data points. And the one on the black line here in blue, that is a predicted data point. So we're looking at this problem here about Landon, keeping track of the number of people inside a music hall, plotted the data, he drew a line of best fit. What does the point 2, 171 represent? So 2 is the hours past 6 p.m., so that must mean 2 hours past 6, or at 8 o'clock. And 171 is the people inside the music hall. So we're going to start with at 8 o'clock. So I know these two are incorrect because it's 2 hours past 6. And then we have to decide if we're talking about what to expect or what exactly was had. Remember, anything on this black line, right, with the blue dot, that is a predicted value, not the exact data. The yellow dots are the exact data. So we're going to say at 8 o'clock he can expect, he can predict to have 171 people. All right. In this one, we're talking about quiz scores, time spent on homework. After I read the story, I read the question. What does the line's y-intercept represent? A y-intercept is an initial value. So I can see here that the initial value, or the initial time spent on homework, of 0 hours. So 0 hours would give you about a 62.5, right? The initial value. So is that a student's expected quiz score if they spent no time on their homework? Yeah. How many hours a student spend studying all year? Nope, that's not your initial value. The change in expected quiz score for every additional 1 hour? Nope, that's a slope. A prediction of a student's quiz score if they spent 1 hour? Nope, spend 1 hour, that'd be here. So we're going with this one. All right, that's how you interpret a line of best fit. Now for the correlation coefficients, we're going to talk about positive, negative, linear, nonlinear, no correlation, weak, strong, or perfect. See how this is perfectly in a straight line? And it's going downhill. So it's a perfect negative correlation. This is pretty scattered, but it tends to be kind of moving in an upward direction. So that is weak. Weak, but it's positive. Tends to be moving upwards. Now what we're going to do is look at some data from some regression equations. And what they're looking for us to find is the strongest negative linear correlation. Well, these are all linear, but they're not all negative. This one is not, this one is not. These two are negative. and then it wants the strongest. So that means I got to look down here at the correlation coefficient. So the strongest of these two, that's what I'm looking at, would be this one, because it is closer to -1. So that is regression equation 2. So again, when we're looking for a strong relationship, we're looking for one of these numbers that is closest to 1. Now you can't go over 1, so this is automatically out. So what we're looking for here, we don't know if it's positive or negative because it doesn't tell us. It just says which one is the strongest. Well, which one is closer to a value of 1? This one. -0.8 is closer to -1 than this is to +1. So regression equation 2 is going to be the winner. Which one is the strongest positive? Well, this one's not positive and that one is okay. So now we look at the strongest numbers. Remember, you cannot be over 1, so these two are out. Alright, average rate of change from a graph. To find the average rate of change, you need 2 points. And in order to have 2 points, you must be given the x values. You are given the x values here, -5 and 3. And what you need to do is find the y values. So here's -5, its y value is 0. Here's +3, its y value is, -35. Now we're going to use the rate of change formula. Oh no. And we're going to do y minus y over x minus x. Oops, that's a 5. Yikes, that's a mess. So -35 minus 0 over 3 minus -5. I'm going to use my calculator to do that math. -35 minus 0 over 3 minus -5. -35/8. Did I do that right? I'll type that in down here. Awesome. So we found your 2 points. You use your rate of change formula, and you're done. One more time. Again, you have to be given the x values. So for us, they are 3 and 6. And then you have to find them on the graph. So 3 is, careful, these boxes go by 2s. So 3 is -2, and 6 is also -2. And that definitely is a horizontal line. So I'm predicting a slope of 0. -2 minus -2 over 6 minus 3. And yes, 0 divided by 3 is 0, which makes sense because my average rate of change connection here was a horizontal line. All right, how about from an equation? From an equation means you need your calculator. So you go to your y equals button, you clear out any old math that's there, so it doesn't confuse you in any way. And we're going to type in this function. X squared minus x minus 8. And we're going to look at the table, and we're going to grab our 2 points. I need a -1, so I'm going to go up here. -1, -6, and 5, 12. -1, -6, and 5, 12. Y minus y, x minus x. I'm going to get 18 over 6, which is 3. All right, last one. Evaluate a piecewise function graphically. So they want you to find the output if the input is 0. So I go to 0. I find my graph, and it touches at -5. So that's my answer. Let's try one more. They gave me the input of 4, so I go to 4. I go down to my graph. Ooh, I'm going to zoom in on that. Okay, I guess it's -2. That was tough for me to see. I really had to zoom in a lot. Okay, now I'm too zoomed in. That was obnoxious. Alright, find f of 9. So I go all the way to 9. I scan down. I get -8. Let's see, do they ever ask you to find the input if they're given the output? I wonder. Let's see. Nope, another input. If the input is -5, ooh, look at that. At -5, it's an open dot here. So the answer would be undefined. But when I scan up, I see there actually is another dot. So it's not here. It's undefined here, but it is defined here. So the answer would be 6. All right, I think you got the hang of it.